Welcome back to our online platform Step Up Bengal to the solution of next question from CSIR Net Math June 2018 of 3 marks. Obviously, this is a single choice question. That means only one option is correct. Now, we have so far discussed from lecture number 1 to 16 all the aspects of Lagrangian and its various forms, including Euler-Lagrange or simply Lagrange equations. In this next lecture, we will be discussing Hamiltonian system, Hamiltonian mechanics. For this, we are simply indebted to this person, this famous versatile mathematician of Ireland, who worked in the field of abstract algebra, physics, as well as in mathematics. So, first of all, let us pay a total respect to this versatile genius of all time. His theory was, in fact, he was a 19th century mathematician, but all his works are still valid even in field theory given by Albert Einstein himself. In field theory also, the contribution of William Hamilton is tremendous. Now, we have already seen that in Lagrangian, L was the function of coordinate, velocity, and time. This Qi was obviously generalized coordinate. Those of you who are new to this channel, please revisit our videos from 1 to 16 on the playlist of classical mechanics, from where you can see what is Lagrangian, etc. Now, this man, Hamilton, produced a beautiful function h which is called Hamiltonian, and that is coordinate should be there, but he has taken a change here. This is the point you should note very carefully. This Qi in Hamiltonian system is replaced by Pi and T. What was Pi? Pi was generalized momenta. That means, simple example is, if half mv square, or rather mx dot square, this is, we all know kinetic energy in Lagrangian system, this is T, and in spring mass system half kx square, that is potential energy, and that is V. Now if we just produce the expression of L, that is T minus V, it will be half m x dot square minus half k x square. And if we now just take derivative partial of L with respect to x dot, we have px. This px is generalized momentum along x-axis, and that will simply be half into m into 2x dot. 2 will be cancelled, so m into x dot. This is obviously mass into velocity, so it is of the form mass into velocity, and this is called momentum. This is the P which famous mathematician and physicist William Hamilton, he inserted this Pi instead of Qi dot. So whenever we have to construct Hamiltonian, we just we have to replace Qi dot by Pi and get the answer easily. Now look at the question here. In this question, Lagrangian, now the conversion rule, this is important, rule for conversion. This is extremely important a question for any kind of exam in higher level. Rule for conversion of L to H, that means Lagrangian to Hamiltonian, this system is different, will be Hamiltonian should be summation of Pi into Qi dot minus L. That means we are already familiar with L. This Pi is now given to be Pi should be del L by del Qi dot. That means if we just take velocity differential partially of L, then we have corresponding momentum. We have discussed in details about this transformation in the previous lectures. Please visit the previous lectures to have clear idea about it. Okay, this is the rule. Now if there are only one coordinate, say x is generalized, only x, only generalized, in competitive exam we obviously will see generalized coordinates as at most 2. In almost all the problems we will see at most 2. So this summation will be extended for only 2, I equal to 1 comma 2. Say for for example r and theta, or say only r, or say only theta, or say only x, or x y, etc. Clear? So look at the problem here. L equal to, what is L? L equal to half into m into L square into theta dot square plus mgl cos theta. What they are given? This is L for simple pendulum. So just let us draw that pendulum. Here the advantage is that we don't have to formulate L because that is already given. So this is our length of string L, this is the mass m, and this is the displaced position. So this is amplitude theta. All these are given here. So we now easily can calculate h. But for h, look at the beauty. Can we call it as a function of theta comma theta dot and obviously time, because if time is not there, theta dot will not be possible. So if we just convert into h, then we should not have theta dot here. Instead we have theta, p theta and p theta and t. Just let me erase this. H will be the function of theta, p theta comma t. Here this theta is the only coordinate, that is generalized coordinate. I have already said that in competitive exam there should be at most 2 cases, or that means 2 generalized coordinates at the most, not in general from n coordinates or so. We will see in all the problems there, don't worry about it. This is h. Now, in this particular problem, this p theta is given to be p. So, in our case, this will be finally h will be a function of theta, comma p, comma t. And that is something they have given. These 4 options are given and we have to choose the correct option. Now, first of all, let us take a derivative of L, that means del L by del theta dot, that will be p, that will be our p, that will be, what will be that, half into ml square into 2 theta dot. Next portion will be 0 because in this quantity ml cos theta there is no theta dot. So this will be obviously ml square, 2 will be cancelled into theta dot. Now what will be theta dot? Theta dot will be p by ml square. Now the question arises that why should we just making this change? We should make this particular change only because in Lagrangian we should have p instead of theta dot. So we should replace theta dot by p by this result. And now h, that should be summation pi into qi dot minus l. What are total number of generalized coordinate? Only one, that is theta. So this should be p into theta dot minus l. We should write down all the expressions. P into theta dot, we have already derived p by ml square minus L will be this quantity, but with minus sign, remember it, half into ml square into theta dot square minus mgl cos theta. So finally we should have p square by ml square minus half into ml square. We must replace this theta dot by p, because in Hamiltonian function h we should not have theta dot. That means velocity component. So ml square into what will be theta dot? Theta dot will be p by ml square whole square minus mgl cos theta, and that should be finally 1 ml square will be cancelled and we will have p square by ml square minus, here 1 ml square will be cancelled, so we will have half into p square by ml square. Okay, this will be clear, and minus mgl cos theta. So ultimately, by adjusting these two terms, we will have the final result as here, p square by half into p square by ml square minus mgl cos theta. This is our required age. Remember, this is our required age. Now, to which option this will match? This will match obviously first option. In here we should have minus sign mgl type, this mgl minus sign is there. So in the options where there are plus signs, that means this one and this one will already be cancelled. We should come to these two portions only. One is minus ml cos theta, here it is also minus mgl cos theta, but these two will obviously make us the answer, because in the denominator we have 2, so obviously its answer is 2 and 3 is cancelled. Now after doing up to this, that means these lengthy calculations, what we have arrived at? We have arrived at h. Clearly this h is the answer. But question comes, in the exam hall, should we just spare so much time to calculate this? The answer is obviously no. Just take a look at one important thing. What is L hour? This is our L. This part is obviously kinetic energy, that means T part. This is V, potential energy part. Look at the beauty. Is there any time component in V? No. Only theta is present, not T. So obviously the theta dot possibility in case of V will not come. That means when V is free from time or theta dot, then to write H from L will be very much easier. We can do it with 1 minute. Within 1 minute we can answer this problem. Look how. This will be the shortcut tricks. This will be the shortcut tricks. Look at what is our L. L is half into ml square into theta dot square plus mgl cos theta. Obviously this is the potential energy part, which is V. Look at this rule should be carefully noted by all of you. This rule, V is free from, you can apply this rule only if this case happens, free from time t, that is theta dot type, that means velocity type. If velocity type terms are missing in missing in V, then you can easily write H as, just make this quantity comparable with half into mass into velocity square, and this portion will always be potential energy. That means here we should have plus sign or minus sign. So this is plus minus V type. This is potential energy and this is kinetic energy T. Now just compare it with this. What is mass? Mass is obviously half ml square, because this is mass into velocity here is theta dot square, and half should always be there, because we remember one thing, half m v square type, this should be converted to half mass into velocity square type, and we should not have theta dot or t in potential energy. In that case, Hamiltonian will be just be, in the numerator we should have always p square, and in the denominator 2 into that mass. What will be that mass? The mass will be here ml square, and just if there is this plus sign, you should write minus sign and put that v here. If this is plus minus type, this will be minus plus type. This is the change. Just change the sign of potential energy. In that case, if it is plus, then you should take minus. If it is minus, then you should take plus. And that will be tremendous achievement in exam hall. P square by 2 into what was mass? ml square, minus, here in the potential energy part we have plus, so this will be obviously this will come with obviously with the reversed sign, and that is the answer. See, it is done with 1 minute, in 1 minute. In 1 minute technique we can do it. Just take the Lagrangian and put p square upwards and then 2 into mass downwards. That means in the numerator we have p square, in the denominator we have 2 into mass, and just take opposite sign of potential energy to have the answer. Now take a look at the answer. Half into, here this mass is there, and minus ml cos theta, and that is the answer. That means 2 is the answer, correct answer. So it will take just 1 minute. But remember, to make these shortcut tricks, we should have potential V which is free from velocity type or theta dot type or x dot type, whatever you can say. Now if these generalized coordinates, as I have taken, at most 2, if they are given say px and py, these two are generalized momentum, then this result will take just summation. That means px square by 2 into mass plus py square by 2 into mass minus obviously minus plus v, potential energy. That will be the rule. Questions are set on this also where 2 momentum are there. We will see in the next videos. So in this video we should stop here and just say goodbye. If you have liked this video, then please share it among maximum number of CSIR aspirants or WB set or any other set exam aspirants, so that they can be benefited. Remember, these shortcut tricks will be extremely important, this shortcut, for exam hall. So goodbye for now.